Hello, welcome. Thanks for joining our diagnostic training session today. Now, if you have any questions throughout the session, if you're watching on Zoom, just look at the top of the bottom of your screen, wherever your Zoom controls are, you should see a Q&A button. Click on that, type in your question, hit submit, and I'll get to those at the end of the session. If you're watching along on YouTube, just feel free to use the live chat function wherever it is on your device, and I'll get to those questions at the end as well. So my name is Jason Gabrenas. I'm one of Snap-on's national diagnostic technical trainers. Been in the training department the last 9 years or so, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep with Snap-on. So I had about 30 different Snap-on franchisees I worked with, as well as the shops that they serviced in order to help everyone get the most out of their diagnostic needs. Then before that, it was 8 years at Subaru. So over time, I was a tech in a Subaru dealership, and over time just became that diagnostic guy in the shop. So I always ended up with the intermittent problems, the drivability problems, the weird wiring problems that would show up. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bay. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today is body shop diagnostics. So I know usually we skew towards the general repair function, undercar, that sort of thing, but body shops need diagnostics too. And then there is a lot of overlap between the body shop world and the general repair world. But there are some things that are going to be more commonplace to be done in a collision repair shop. Things like maybe headlights and body panels. Inside those body panels, oftentimes there's wiring harnesses, there's modules, there's other things that need to be replaced, reset. Some body shops, they've avoided it for a while. Over the last, probably 10 years or so, I think it's become a lot more mainstream, a lot more commonplace to see diagnostics or diagnostic tools inside a body shop. Oftentimes they'd sublet it out. Sometimes they hire somebody in to be just their diagnostic specialist in the shop as well. We'll talk about a few different things related to body shop. And also, if you are a general repair shop and maybe you have body shops sublet to you, this would be a good little background, just to be a little bit more aware of some of the body shop things that are going on out there. So why do body shops need diagnostics? And as I said, over the course of the last decade or so, it's really become more and more commonplace for them to have diagnostics, but not all of them. I'm sure there's still some that are holding out. There's some that have embraced it completely. So it's really just kind of all over the board as to whether or not they've adopted this. Main reason, though, as you know, if you've worked on cars in the last 5-10 years, vehicles are getting a lot more complicated. Lots of different systems, many different functions and configurations and resets and relearns. In order to diagnose a problem with a vehicle, it's not necessarily a straight ahead answer. It's a lot of complexity. Also, the mandatory pre and post scans back in 2016. We'll talk a little bit more about this as we go, but back in 2016, manufacturers started mandating that there needs to be a pre and a post scan on every vehicle that gets in a collision. They also need documentation, but going along with that mandatory pre and post scan, you need to document what has been done with the vehicle. For example, if you have an ADAS recalibration you do, maybe you need to submit an ADAS recalibration report, which is also available. Of course, they need repair information as well, not just here's where the body parts go and here's how to remove or install a bumper or anything like that. There's wiring harnesses. They need to understand, wiring diagrams. They need to know locations of components. They need to know, just the general removal and installation of some of these things. And if there is a relearn or calibration that needs to be done after the fact as well, there's a litany of relearns, calibrations, resets, functional tests that may need to be done on a vehicle, and the shop needs to definitely be aware of that after the fact. So talking about vehicle complexity, as we know, there can be more than 100 modules on a vehicle. Nowadays, a left window switch is considered a module on some of these vehicles due to the networking that's going on there. And on average, vehicle technology changes about once a month, about every 38 days on average, they say. So a new system comes out, a new procedure, something like that, about every 38 days. And of course, over the last 10 years or so, we've been seeing vehicles with ADAS features added. and they're not optional anymore. Most times they are, at least some of the ADAS systems are standard on a vehicle. It's usually going to be a camera or maybe a radar, cruise control, things of that nature. And those need to be repaired. There's specialty repair functions that need to be done with that. And there's many different methods for repair and diagnosis between the different manufacturers. You do it one way on a Chevy, it's not going to be that way necessarily on a Mazda or a Nissan. They might all have their own different types of ways to go about things. So they need to keep up to date on that as well. So think about vehicle complexity, right? The airbags, we've had that for a while, but like adaptive front lighting, adaptive front cruise, seat position controls, heated and cooled seats, lane departure warning, voice and data communication, environmental controls, active cabin noise suppression. There's another one that's been around for a little while now, and battery management, lane correction, lane detection. All of these different systems combine to make a very complicated vehicle. And it's not just the diagnostics that are making the vehicle complicated too. Some of the materials that the manufacturers are using out there require specialized welders, specialized cutting implements in order to work on these vehicles as well. So it's not just the electronics. That's where we're going to stick to for tonight. But the body shops have become aware that, a lot of different technologies going on in these vehicles now. So as we said earlier, starting in 2016, manufacturers began mandating those pre and post scans after a collision. So if it comes into the shop, we need to do a pre-scan. This is going to show the vehicle's condition on arrival, of course, what codes are in there, because there can be systems that have codes that don't set off a light. Some systems don't have a light associated with them. And then, of course, a post scan is going to verify that the repair is complete after the fact as well. So they want to have, well, let's see what's going on with this vehicle when it comes in. After we've repaired it, before we return it to the customer, we want to verify there are no codes left, that all the faults are clean in the vehicle, and we don't have any problems going forward. So they wanted to verify that. So here's just a selection of the manufacturers that they all have these things called position statements they put out over the last few years. Pretty much every manufacturer has one at this point now when it comes to pre and post scanning. So it says, this is an excerpt from Toyota, I believe. So considering the fact that a capable scan tool is the only way to identify some DTCs, Toyota requires that repairers perform a health check diagnostic scan if a vehicle has sustained damage as a result of a collision that may affect electrical systems. And as we mentioned earlier, those harnesses, it's probably going to affect an electrical system somewhere on that vehicle. Additionally, Toyota strongly recommends that repairers perform a health check diagnostic scan before and after every repair to identify and document DTCs. If DTCs are identified pre-repair, then they can be considered to create a complete vehicle damage analysis report. So as we're doing our estimation as to what may be wrong with this vehicle, we can include those codes in there as diagnostic time. If DTCs are identified post-repair, then they can be diagnosed and addressed before returning the vehicle to the customer. So in their mind, and I would tend to agree, is we would want to make sure the customer gets the car in as good, if not better condition than when it came in. Some codes could be collision related. Some codes could have been from prior, but we want to return the customer with essentially a like new or as close to like new as we can get on a vehicle after a collision, of course. So it is just about every manufacturer has guidance on this now, and they all say you want to do a pre-scan, you want to do a post-scan. So as you may know, or maybe you don't know, all Snap-on scan tools have the capability to generate this vehicle system report. Now, we've had these pre and post scan functions since 2014, and we've enhanced it over time. And now we have this nice visual for a customer. It's going to give us our green and yellows, whether it's kind of like a pass fail. It's going to have all sorts of information. It's importantly, though, it has the date and time that the scan was performed. So that is important for insurance purposes. You can see when they scanned it. It's going to have the vehicle information, including the VIN. As long as the VIN's auto ID'd, it'll go, or you can type it in manually as well. And of course, it gives the vehicle year, make, model, engine. Also can be customized with the shop's information at the top, of course. We go down to the bottom, it gives us an overview, health by system. So green is good, yellow is, let's take a look at that. We might have an issue there. Then if we scroll down a little bit further, we get our details. So these are the systems that had codes, and these are the codes that are there. And then whatever readiness monitors are complete or not complete. So in the case of a vehicle that may have to go for an emissions inspection or safety inspection as well, because oftentimes they'll check that in states that need it, those readiness monitors need to be complete. Also, by running the readiness monitors and knowing that they all passed, then you can be a lot more confident you're not going to have an engine light come on and you get a comeback a little bit later. So it's true for the general repair shop. It's true for the body shop, right? We want to make sure that all the readiness monitors are complete. We take a good road test. We make sure that that vehicle is done. Now, it's not as big of an issue nowadays. It used to be more so of an issue back 2016, 2017 or so when this first started coming out and first started becoming available. Is, well, how am I going to get paid for that, right? Well, now body shops, this is actually pretty lucrative, can be a good source of income for a body shop, because most insurance companies at this point are like, okay, yeah, we'll pay you for the pre and post scan. Sometimes it's an hour, sometimes it's half an hour. I guess it depends on the insurance company or the adjuster or what have you. But yeah, they'll pay for a pre-scan, post-scan, and oftentimes I've spoken to quite a few body shops that say we'll do multiple scans in between. So we do our pre-scan to start, roll it into the estimate, get paid for that. Then we'll roll it into, okay, well, we've reached a major milestone in this repair. So now we'll scan it again and see where we're at. And then they'll get paid for that one. And then when it's fully complete, they'll do another scan at the end. And then, okay, clean bill of health on this car. There we go. Most insurance companies, from what I've been told from body shops I've spoken to, say, yeah, they're pretty good about it now. You really don't hear too much about them giving them any issues with that. So there's some people who made this their business model. So we've had people out there, they'll go and they'll be mobile. So on body shops that don't have diagnostic equipment that can do this, they'll go around and they'll go to the local body shops in the area and they'll pre-scan and post-scan every vehicle that comes in, and they'll get paid for it. So it can be a good source of income depending on what your business model is. Having these mobile folks come out, and it worked out great for them. I'm sure they're probably still around too, because there are body shops that don't see investing in a scan tool for one reason or another. Maybe it's because they say we farm it out, and that's okay. Whatever your business model is, it's okay. Also, our pre and post scans, though, will also upload to the free Snap-on cloud service. So the nice thing about that is you can share those with your customers or insurance companies. You can just send them a link. You can do it on your phone. You can do it on your tablet, laptop, desktop, PC, Mac. Doesn't matter, as long as it has a web browser that can get to the website, then we can share it from that website. So we can download it, we can print it. We could also email it, text it, share it, copy and paste it into our estimating software or our management software. So once the vehicle is scanned, we talked about pre and post scans there. So once it is scanned and we know, well, where are some issues with this car? Or maybe it's visually, it's pretty obvious where the problem is with the car. Well, the fender's gone or something like that. But often once that's done, the vehicle, the repair can begin. Now, of course, body shops also need access to vehicle repair information like shop key or Mitchell. They don't have necessarily, depending, they may only have estimating software, or they may have just body repair specific software that they use. So they do need access to that repair information, wiring diagrams, removal and replacement, reset and relearn information. Most body shops will have that existing estimating software. So really your workflow is going to be the car comes in, either on a hook or however it comes in. First thing you want to do is do a little triage. You want to do a pre-scan, and then you'll input that information, use that as part of your initial estimate in there. And the two most common estimating collision repair software is going to be CC1 and CCC1 and Mitchell International, which is no relation to Mitchell One, by the way. Once the estimate is through and approved, then of course the repairs to the vehicle are made. Once the repairs are done, we want to do our post scan again. Then we write up our final report, what have you, in our estimating software, and then out the vehicle goes out the door, hopefully with a good, happy customer. Also to note, if you happen to have a Windows-based scan tool, you could install your estimating software on there. We have plenty of body shops out there that have done that, since it can run on any Windows-based machine, so they can install it right there. And some shops have had, they have like a triage cart, so they'll have a Windows-based scan tool in a cart, and they get the nice big touch screen. They can just kind of have it right there in the intake bay, the write-up bay, wherever they're doing their estimates, and they can do their estimate. Or if you had to go out to the parking lot, let's say, I'm going to take my Windows-based tool out there, and then a parking lot, I can open up my estimating software, go around the vehicle. Windows-based tool's got a camera in it too, so you could probably utilize that for taking some pictures as well. Kind of have an all-in-one unit, little triage tool out in the parking lot. Possibilities are there since it is Windows-based. It allows you to do that. And of course, repair information. We said they needed repair information, and I think we agree. So fast track intelligent diagnostics on many of our tools now could be useful to them, given their quick access to their TSBs and their top repairs for that particular code, and all their data, functional tests, guided component tests, and real world information in there as well. So body shops, oftentimes, not always, but oftentimes, they'll have one of their technicians that have been working in the shop, and they'll just kind of move them over and have them, okay, well, here's a scan tool. Let's try and figure out these problems on these cars. And sometimes they just hire a dedicated diagnostic tech. Now, either way, so that tech might not be familiar with this particular problem on this particular vehicle. So having all that information in one place can certainly be helpful to them as well. And then repair information, of course, like our wiring diagrams, right? So having ShopKey Pro for my testing procedures, my guided component testing procedures, all access to all the TSBs on the vehicle, real fixes, et cetera, always good to have right at their fingertips. And of course, the wiring diagrams, as we said, as well as, well, guided component tests. You might think, well, why does a body shop need guided component tests? Well, if they have a failed component, before they replace it, they're going to want to test it out. That's what we always profess. You want to go and test the part to be sure that it has failed. It also has component locator information in it as well. So let's give you a little example on a 2016 Chrysler Town and Country. This is a story from a body shop down south. And they had one of our scan tools, and they said, well, we got a Chrysler comes in, it got hit in the driver's side front, got hit in there, fender was pushed in and everything. And they had some problems with the throttle and not some codes of the throttle and not starting. So they had some issues. So they had to go into guided component test. And of course, if you don't know about our guided component test, it's a database of over 5 million individual tests. Goes back to 1981, all different components and all different systems on the vehicle. So things like ABS, body electrical charging system, driver assist, ADAS, HVAC, starting, transmission, and of course, engines. We wanted to go in there. And once we load into the system, it's going to give us a list of components, of course, but we'll go into throttle control system to find out about maybe the throttle position sensor. Maybe they had a code for that. If we go into component information, it's going to tell us how it works. So in this case, it's got 2 throttle position sensors. As the throttle opens, both of these signals will vary accordingly. So one goes, what happens is one goes 0.5 volt to 4.5 volts, and then the other one goes from 4.5 volts down to 0.5 volt. So the PCM expects the values from 1 and 2 to equal 5 volts at all times, wherever it opens. So that a lot of throttle position sensors, dual sensors, work that way. They'll add both together. So 0.5 volt closed to 4.5 volts closed will give us 5 volts. And then at wide open throttle, 4.5 plus half, that gives us 5 volts again. So it should see a 5 volt. When you sum the 2 values together, it should see 5 volts at the end. So here's our harness connector, of course, and then our positive, negative signal wires, etc. And then also alternatively, there's a PCM connector right here. It says best test location is going to be at the throttle body, and TPS are located on electric throttle control module on the side of the throttle body unit. But if I needed to test it at the PCM, or I needed to test to make sure the signal was getting to the PCM, I could test it there. So where is the PCM on this vehicle? So we go into PCM, we have a module location section, and it's going to say, in this case, it's located at the left front fender well. Inner fender liner must be removed for access. So as I said before, in this case, this vehicle got hit in the front left. They hadn't really gotten too much of a visual on it. And then they realized, oh, well, the PCM's there. So maybe the PCM got hit as well. So if they know the inner fender liner needs to be removed, so we know that it's in the fender well there somewhere, and that could be a problem. So maybe it needs a computer at that point. So you see, the manufacturers don't always put their control modules in the best places either, as you probably, or their battery. Chrysler's good for that too, putting their batteries in the fender well as well. So if you get hit in the left front on one of those vehicles, you could have quite a bit of stuff in there that needs to get repaired more than you might think, just because of that. So once we go through and we diagnose, and then of course we repair it to the manufacturer specifications, oftentimes, many times, a large amount of times nowadays, there's often a calibration or relearn that needs to be done. Some examples that would be kind of more body shop specific, but of course you could see these in general repair as well. ReZero occupant detection sensors. So in the seats, they have occupant detection sensors that need to be calibrated different ways. Recalibrate window motors. Sometimes it's just a simple button combination on the window. Sometimes you need to use a scan tool. Front camera. If I have to replace a windshield, I have to re-aim the camera. Radars. Blind spot monitors in the back for radar as well. All those ADAS systems on a vehicle definitely need calibration. Sometimes it's driving down the road. Sometimes it is using a scan tool. So need diagnostics and diagnostic information for that as well. So here's an example on a 2016 Mercedes-Benz. They actually had a recall on this as well. The following procedure will guide you through all steps required to perform a complete initial setup of this weight sensing system control unit. So that is the passenger seat weight sensing system. So that what it does is it turns on the airbag if it senses enough weight. If there isn't enough weight in the seat, then the airbag doesn't turn on. And that'll help if there is a collision. We don't blow all the airbags on that side, and we can save a little bit of repair at that point. Because oftentimes, I know like when Subaru first came out with this, for example, the way the dash was set up, when that airbag goes off on the passenger side, the dash is ruined. You need to redo the whole dash. It's not just a piece that pops off. It's the entire dash splits open and the bag comes out. So that's really when they first started doing that. So, well, if I'm just driving, if I'm the only one in the car and I get in a front end collision and my airbag goes off, do I want to have to replace the dashboard for an airbag that didn't really do anything because the passenger there was no passenger? So they came up with these systems pretty much for that reason, because we don't want to have excessive repairs if we have a problem there. And we do want to make sure the airbag does go off if there is a passenger in the seat. So these weight sensing systems. So in order to do this test, we want to make sure there's nothing on or under the front passenger seat. It needs to be empty. Front seat must be moved to approximately the center position in this case. You want to make sure you read these instructions carefully, because as we said earlier, every manufacturer is a little bit different with their system. So in this case, you want to make sure there's nothing on or under the front passenger seat, and it's in the center. Corresponding belt buckle needs to not be fastened, and we need a special tool, which we're going to show you in a second, is required to do this as well. Turn on the ignition. You'll be guided through the following steps. You're going to do a 0-point setting, and then you're going to do a functional check by applying weights, which is this special tool. Must be placed in the seat sitting surface at a distance of 2.5 to 5 centimeters from the backrest. Then we'll erase the fault memory, and then we'll check the component again. When the function is ended, the fault memory is erased, and initial startup must be completed successfully. Otherwise, it's not going to work. So in this case, this is the special tool there. It kind of looks like a set of legs, and it's got a metal weight in there, and it's going to compress the pad, so to say. It depends on what the manufacturer uses for a system. Now, for example, back again, Subaru's first couple years with weight sensing, they were so sensitive that if you so much as cracked one of the bolts, you had to do a procedure like this. And the first couple of years, you had to use the special tool in order to do it as well. Later years, it only lasted a couple of years. After that, and really what most manufacturers use nowadays is going to be just a 0-point calibration. So you empty out the seat, you put it in a certain position, and that's basically telling the computer, here's where 0 is. This is 0 pounds. Do your weight from there. So there's two different types. Those are the two main different types of weight sensing systems in the automotive world. One, you need a special tool. One, you don't. So just be aware that sometimes you may run into a vehicle that does need that. Now let's talk about an ADAS calibration. So in this case, this vehicle had been in a collision. It was a 2017 Genesis G80. So if you don't know what Genesis is, that was kind of the spinoff of Hyundai. It was their higher end vehicles, and they spun it off in their own brand. So they're the G70, G80, G90, and this was a collision in the front, and it needed a radar calibration. So according to the manufacturer's information, first it needs to be vertically level, and then it also needs to be horizontally level. So this we got from a gentleman named Mike Reynolds. He's down in South Carolina, and he does mobile ADAS repair, also pre and post scans as well. So he's a mobile guy, and he came out and did this, gave us this information, allowed us to use this. So in this case, there's my 90 degrees. I have my inclinometer. There we go. Or a digital angle gauge, if you want to call it that as well. But it gives me 90 degrees straight up and down. That is probably the more critical measurement than the side to side, because the beam's pretty much going to be pretty close. In this case, it's down and to the left a little bit by 0.2 of a degree. So that's within spec there. So we wanted to make sure we do that first. Next thing we want to do is we're going to go into our scan tool, pull up the service resets and relearns, and find there's one under ADAS for replace or calibrate the front radar. So we replace the radar, we're going to calibrate. We go to functional resets, and it gives us our SCC alignment calibration. So smart cruise control is SCC. Purpose of this function is to align sensors if sensors are replaced or the vehicle has an accident with structural damage that required wheel alignment. The case when this needs to be done is when the radar sensor is changed out in case of light contact accident or a strong shock against the sensor from vehicles not detected while running on the road, or steering angle sensor is replaced or calibrated. So if we ever had to do an alignment on this vehicle, it needs to be done as well. We need to have no codes and the ignition needs to be on. We'll hit continue. I thought this was interesting. It gives you a static and a dynamic recalibration. The dynamic one's going to be easier driving down the road, so I don't need special targets or anything. So we pick that, and it's going to tell you how to do that. So attach a new radar sensor, make sure it's perpendicular, 90 degrees, and so on and so forth. Drive above 50 kilometers an hour for 10 to 15 minutes, and avoid excessive steering and lane change, low speed driving on roads with fewer obstacles, or driving in bad weather. Continue. This also I found was interesting as well. So once we get to this screen, it's going to say it's already started. Disconnect the diagnostic tool and drive the vehicle. So in this case, we can leave the tool in the shop and drive the vehicle. So they continue, and you drive it down the road until the service light that's on the dash right there goes out. Once it does go out, you verify the cruise control works. Once that's done, the repair is complete. Now, of course, it's almost complete, because once that's done, we also need to do a post scan to verify that the repairs are complete and there's no codes in the vehicle. And then, of course, we can deliver it to the customer, and you can feel confident that repair was completed properly and the car is in good running order as well. All right. So let's go live on the tool here, talk about a couple of these specific things. Pull a couple vehicles up here. Let's see. So we already talked about the seats. So let's go in here. Think about some other things that might be body shop related. How about lights? Might have to replace a headlight, tail light, turn signal lamp, something of that nature if you get in a collision, I would imagine. So there's a few different places we can go in here to look at a couple different things. So first off, ADAS. This is on a 2014 BMW 5 Series, by the way. But ADAS, we got cruise control, cameras, lane change warnings, park distance control. All of these need calibrations as well. If I go down a little bit further, we got body controls, and then we have doors and windows, and then we have engine-related HVAC instrument cluster, lighting and controls. So if I go into my front headlight electronics here, it's going to have codes and data, of course, but then we have functional tests. So there's a special function in here for teach-in front light electronic turn signal. So if I replace a turn signal, if new front light electronics have been installed, they must be encoded first in order to carry out the teach-in procedure. If the control units have been swapped, the turn signals must be taught in. So should the turn signal be taught in now? Yes. So I have to teach the vehicle turn signals. Interesting. It's going to go through, it's going to do its thing for a few seconds, and then it's going to give us a status message at the end. Reset completed, hit exit, and then there we are, back to the beginning. There's also on some of these vehicles, you need to teach in the LEDs as well. So if I do a headlight, I need to teach in the LED headlights. There's a function available for that. There's a function available for multiple different things. You need to make sure that you have the proper headlights in there. I know Ford had a bulletin on LED headlamps causing some issues on some vehicles if they weren't set up properly as well. So just be aware there's a lot of things in there. We got night vision as well. That probably needs a calibration. Seat modules for the occupant detection system. Steering and chassis. If I have a collision, I oftentimes need to do something with the dampers, air suspension, electrical suspension, things of that nature need to be done as well. I know with anti-lock brakes on a Subaru, they also had the vehicle VDC for stability in there, needed to be as a function that needs to be done on those as well. So that's an example for lights on a BMW. Let's go into this Escalade, 2018 Escalade, and see what we can find. So on this one, once again, tons of ADAS, active safety control, camera systems, radars, multiple radars, video processing. So a lot of stuff would need to be done there. Assist step control module. So you got to relearn the side step that comes out. How about the liftgate module? So we have a hands-free liftgate sensor control module calibration. So that's one where you kick your foot underneath and it opens the liftgate for you. Applies to vehicle equipped with this feature. Do not attempt to run this test unless referred to by the service information. Turn the ignition on. And it's going to go through and just do its procedure. It takes, I think, maybe 10 seconds. Okay, and then it does the calibration. Calibrations are complete. Liftgate maximum open position learned. So if I have to do the rear liftgate, if I do any work there, we have to do this procedure as well. Unlock all doors, close the liftgate, ensure there's sufficient space behind and above the vehicle to open the liftgate. Hit continue, and then it's going to give us some data relating to the switch, and then caution liftgate will open. We hit continue, and then it closes. And then it should go through the range of travel, and it gives you a pass fail right there. So it'll tell you if the learning is in progress, and if pass and if fail right there. So that's a pass fail test. And then it will tell you whether or not it was successful. In this case, we're on a demo vehicle, so it's going to be unsuccessful. But lots of different resets, relearns, calibrations that need to be done with those. Oh, that one also has a seat too. Let me reactivate that. That one has a seat procedure as well that I want to talk about. So should have occupant detection. Let's see. Where are they hiding here? Seat controls. There we go. Seat model. I think this one had a seat. Functional tests. Adjustable pedals. Passenger mirror. Oh, maybe this one didn't have it. Haptic system as well is in there. Oh, no, I guess that one didn't have it. I thought it did. All right. That's okay. No problem. We have another one that does. That would be this Hyundai Santa Fe. 2019 Hyundai Santa Fe does have a seat reset relearn for that. Okay, so in this case, this occupant detection system right there. And then we have a system tests and a PODS reset. So PODS stands for passive occupancy detection system. And this is used to reinitialize the ECU. You need to do this when the passenger seat is empty, and then remove items from the seat that may have caused failure. After turning the ignition key on and off, try again. Auto mode is selected when replacing the seat assembly or seat foam. Manual mode is when replacing the ECU itself. So we'll go to auto mode. Let's say we replace the seat or remove the seat from the vehicle. You need to do that as well. It's just a simple procedure. You just move the seat all the way to the back, put the seat back up, and then it'll replace that as well. Another thing we want to be considering as well is, let's say we're doing a like a lane departure calibration on this. So we can do a system test, and we can do reference point calibration tests. I don't know if it's going to let me go through this whole thing. This one uses a target, so it may or may not let me do this. So it gives me some calibration points. And with that, I should have now an ADAS report. So this ADOS report here is a recalibration report. I talked about this earlier that you may need to use for a insurance company purposes as well. So it prints out pass fail. So in this case, it's completed. And then you can check off pass fail. You can put in any certification IDs that may have, technician's name, signature, all that information. Once you get into an ADOS test, it'll allow you to print this, save this. When you do save it, it does upload to the Snap-on Cloud, also saves to the vehicle record, can be shared with, as I said, insurance companies or the customer, things of that nature. So that is Body Shop Electronics and Diagnostics. Hopefully we got a few tips and tricks, learned a few more things about how body shops go about with diagnosing vehicles and some of the hoops they have to jump through as well with those pre and post scans and documenting everything. So next week, we are back on TPMS operation and testing. So we're talking about different tire pressure monitoring systems, different ways to diagnose them, reset them, relearn them, different pitfalls you might run into, a couple different scenarios, walk through with the scan tool as well. So if you want to join me next week, 6 and 9 Eastern, as always, if you want to join me on Zoom, go to snapon.com/OT, register to save your seat. The 6 p.m. class goes live to YouTube. So in that case, it's youtube.com/Snap-on Diagnostics. If you are watching on YouTube right now, please make sure you're subscribed and give a thumbs up to the video and ring that bell. Make sure that you get notified anytime we do have some live content or some other pre-recorded content. We just shot a whole bunch of new quick tip videos as well. So those will be coming out over the summer and fall as well. 9 p.m. Eastern goes live to my Facebook page. So if you want to check me out over there, you can look me up. As of right now, this is class number 47. So this is being recorded live to YouTube right now. So if you want to watch the replay, you can go to youtube.com/Snap-on Diagnostics. There is a playlist with all of these videos on there, plus some other training that I've done as well live for different organizations as well. So that's up in there. So things like ADOS, code-based diagnostic workflow, lab scope, body electrical systems, forced induction, multiple different topics. If you want to learn, they're all about 30, 40 minutes long or so. Go check those out as well. Now it's time for Q&A. If you have any questions, just please make sure you put them in the chat box or in the Q&A box on Zoom. I also want to make sure talk about my buddy Al, who also does free diagnostics training. He does scan tool specific training, hands-on type training for Apollo, Zeus, and Triton, Monday, Wednesday, and Thursday nights. Same time, 5 and 8 Central, 6 and 9 Eastern. Go to snapon.com/OT to register for those as well. So it's a very thorough class. First hour, any night is going to be specific to that tool, but it's going to be things like, let's set up your Wi-Fi. There's a lot of functions on the tool require Wi-Fi in order to function. So we're gonna make sure that's set up. We're going to set up your free Snap-on Cloud account so you can make sure you can upload pictures and scan pre and post scans, things of that nature, share them with your customers. And then walk through code to completion, real life scenario on fast track intelligent diagnostics. See how this can help you diagnose a car faster, easier. After that, that's the first hour. So that's the Apollo class. On Wednesday and Thursday, since those tools also have scope and meter in them, it goes through another hour after about a 5-minute break in between and goes through all the scope and meter functions on the tools as well. So a lot of real world content, a lot of good information there. Al's been with us for well over 30 years. He is a deep well of Snap-on scan tool knowledge. He's been everywhere, man. So definitely worth your time to check that out if you want to get more information on any of those tools. Now let's get to questions. So not seeing anything on Zoom. That looks good. Abel, welcome. Thanks for checking in, saying hi. And let's see, Raymond says, what's up, brother Jason? Always a pleasure to have you coming in and saying hi. And the Winton, hello. Thank you, appreciate that. Abel also says he was in a collision in 2018 with a 2016 Maxima. The car was a total loss. I think that is somewhat of the way things roll nowadays, right? With so much technology on these cars and how complicated they are and the complicated fixing. It was only a 2-year-old car. And it was totaled already. So, you hear those stories all the time too. And sometimes they don't even seem like it's that bad a hit. Just, oh yeah, it got hit in the left rear and now we got radar sensors and calibrations and things. And it's worth more than the cost of the car to fix the back. So yeah, I can definitely see that happening nowadays. All right, with that, I'd like to thank everybody very much for taking a little bit of time out of their day to spend a little bit of time with us. And hopefully we learned a few more ins and outs of Body Shop Diagnostics. Hopefully you can join me next week for TPMS. And with that, enjoy the rest of your week. Enjoy your weekend and take care.